My name is Anthony Nathaniel, and in this particular episode of Crash Mathematics for SS2, we're dealing with quadratic equations. Now, in this video, we're dealing with quite a handful, and we're talking about solving a quadratic equation by factorization, by using perfect square method, by using completing the squares method, and then using quadratic formula method. We'll also be deriving the quadratic formula. Hooray! Then lastly, we'll be dealing with how to form a quadratic equation when given its roots, and then how to look for the roots of a quadratic equation. And we'll also finally cap this cap it up with how to use quadratic equations system in word problems. So first of all, let's deal with these steps one by one. So first of all, we have quadratic equations by factorization. How do you factorize? So let me give an example. We have 2x squared 2x squared plus 13x equals 15. So if 2x squared plus 13x equals 15, now we have in this question, let me adjust the so it becomes clear. Now if 2x squared plus 13x equals 15, we are looking for the value of x. This is a quadratic equation, and then we are going to test if it is factorizable. So let's try. Let's 2x squared. Let's move every coefficient to the every term to the left hand side. 2x squared plus 13x minus 15 equals 0. Now, having done this, we are going to multiply the first term and the last term. So that with 2x squared plus times minus 15 is what? That's minus 30x squared. Now, having done that, we are going to divide this product into two terms, such as those two terms, their product will give us this term, and then when we add them together, they will give us the middle term. So these terms, we could use 15x and minus 2x. Because when we multiply 15x by minus 2x, we get minus 30x squared. And then at the same time, when we add them together, when we look for the sum of these terms, it will give us the middle term. So let's substitute our new term. We'll substitute these two terms for the middle term now. That will be 2x squared plus 15x minus 2x minus 15 equals 0. Now the next part of the question is to factorize. Now we could factorize it this way. So what's common to these two is x. X is common. When we factorize 2x squared, we'll get 2x. When we factorize 15x, we'll get 15. Then closing brackets, what's common to this place is minus 2. When we factorize minus 2, we'll get x. When we factorize minus 15, we'll get or rather minus 1 is common instead of minus 2 rather. Minus 1 is common. When we factorize minus 1, we have 2x left. When we factorize minus 15, we get plus 15 left equals 0. Now you can see that from these two terms again, we still have 2x plus 15 common. Let's factorize that out. 2x plus 15. When we factorize this out, we have in the first term we have x left. Then when we factorize 2x plus 15 out, we have minus 1 left in the second term equals 0. So you can see that at the end of the day we have a product. Now this product equals 0. So if we have a product of 0, that means either of these terms will be equal to 0 for us to have a result of 0. That means either 2x plus 15 equals 0 or x minus 1 equals 0. That means when we solve this equation here, we have 2x equals minus 15 or x equals 1. When we solve again, we have x equals minus 15 over 2 or x equals 1. Now the implication of this is that anytime you substitute either minus 15 over 2 in your equation or you substitute 1, you are going to get you are going to satisfy your equation. So that means if you substitute 1 into this equation, you will get 0. If you substitute minus 15 over 2 equals 0. So these are the roots of the equations, and these are the values of x. So another way of solving factorization is by using perfect squares. So for example, if we have x minus 3 squared is equal to 16. So if we have x minus 3 squared equals 16. So if you are solving using perfect square, all you need to do is you take the square root of both sides. That's the square root of this and the square root of this. That's the square root of x minus 3 squared is what? That's x minus 3 equals the square root of 16 is 4. Now if x minus 3 equals 4, the square root of 16 is plus or minus 4 rather. Now if x minus 3 equals plus or minus 4, that means x equals what? 3 plus or minus 4. So 3 plus 4 will be 7, or 3 minus 4 is minus 1. So x will be 7 or minus 1. So anytime you are solving equations with perfect square, you often get two answers, and then you are dealing with plus or minus. So when you do the plus value, you get the plus answer, which is the first root. Then when you look for the negative value, you get the second answer, which will be negative root. Now let's talk about completing the square method. Now before that, let's give an example to illustrate completing the square method. Now completing the square method is the value that will be added to a second degree equation of an unknown in order to make it a perfect square. So for example, when we have x squared plus ax plus b. Now yes, there will be something we have to add to this equation to make this equals to x plus b squared, x plus p squared. Now if we open this equation, we'll have x squared plus 2p plus 2px plus p squared equals that. So this will be equivalent to this. Now x is equivalent to x, so that means ax will be equivalent to what? 2px. So in that case, a will be equivalent to 2p. That will be our first equation, or equivalent. Now the next one, that means b will be equivalent to p squared. So we want to see that for this to be an equation, for this to be a perfect square, we have to make a equals to 2p and make b equals to p squared. So you can simply say that if we convert a to a form, then that a equals to 2p and b is equals to p squared, that would be it. So if a is equals to 2p, then let's say p is what? P is a over 2. So that means x plus a over 2 plus p squared will be the form we need to get this equation to a perfect square. So in that case, we are going to have the coefficient of x. We are going to look for the coefficient of x, and then we are going to square it. So so that means this will be equal to x plus a over 2 square. That would, because p is equal to a over 2. So x squared plus ax plus b, when we convert it to a perfect square, will be x plus a over 2 square. So this simply means that anytime you want to convert, you make it of completing the square method, you simply have the coefficient of x, you have the coefficient of x, and then you square it. So because this third term will be the square of half the coefficient of x, because this is p squared. So because b is p squared, so b will be what? A over 2 square. That's the square of half the coefficient of x. So you are adding the square of half the coefficient of x to both sides. Just add the square of half the coefficient of x to both sides. So let me give an example. Now we have to solve let's solve x squared minus 8x plus 3. So let's solve x squared minus 8x plus 3 equals 0. Now x squared minus 8x plus 3 equals 0, right? Now what must be added to this equation to make it a perfect square? So let's say in this case, let's move the constant term to the right hand side. That will be x squared minus 8x equals minus 3. Now there must be something we must add to the left hand side to make it a perfect square. So let's say we must add half the coefficient of x. So the coefficient of x is minus 8, Abi. That's minus 8. So let's half it. That will be minus 8 divided by 2. That's minus 4. So this minus 4, we are going to square it. That's the square of minus 4 is 16. So we are going to add 16 to both sides. That will be x squared minus 8x plus 16 equals minus 3 plus 16. So in other words, we have converted this to a form of x plus a over 2. So where a is minus 8, that means a over 2 what? Minus 8 divided by 2, that's minus 4. So x minus 4 squared is now a perfect square equals, on the right hand side we have minus 3 plus 16, that's 13. So when we look for the square root of both sides, that means x minus 4 equals root plus or minus root 13, and then at the end of the day, x equals 4 plus or minus root 13. So that's a demonstration of how completing the square method works. So then finally, let's go on to the last method for this video, which is the quadratic formula. So this quadratic formula, it's something that we'll be introducing in this SS2 course. We didn't talk about it in the SS1 course. because it wasn't for that level. Let's talk about the derivation. How did we get here? How did you get to this course, into this stage of quadratic formula? So this is simply the derivation of quadratic formula. When you have a quadratic equation like ax squared plus bx plus c, so how do you get the quadratic formula? So that will be ax squared plus bx plus c equals 0, right? Now we're looking for what will be the quadratic what will be the value? Ax squared plus bx plus c. Let's divide both sides. Let's divide every term by a. Divide by a, divided by a, divided by a, divided by a. So ax squared divided by a will be x squared. Bx divided by a is b over bx over a. C over a will be plus c over a equals 0. Now, having done that, let's move this constant term to the right hand side. So x squared plus bx over a equals minus c over a. Now after that, we are going to look for the term that will make this a perfect square. So from our completing the square method, you can see that when we have the coefficient of x and we'll square it, we are going to get that term that will make it a perfect square. So in other words, the coefficient of x is what? B over a. Let's have it, let's divide by 2. So b over a divided by 2, that's b over a times 1 over 2. That's b over 2a. Now we are looking for a term that is the square of this, that's b over 2a squared. So let's say x squared, when we add b over 2a squared to both sides, x squared plus bx over a plus b over 2a squared. That's the square of b over 2a. So the left hand side, then we'll do the same thing to the right hand side. That's b over 2a minus c over a. B over 2a minus c over a. B over 2a squared rather. Now having done that, let's simplify this. This will become what? X plus b over 2a squared equals b squared over 4a squared minus c over a. Now this is simple enough. Well, next, what we're going to do is we are going to look for the square root of both sides. But before that, let's simplify the right hand side. So this will be equals to what? The LCM is 4a squared. 4a squared. So that's b squared minus 4ac over 4a squared equals x plus b over 2a squared. So now we are going to look for the square root of both sides. That means x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 2a. Then let's move the b over 2a term to the right hand side. That will be x equals minus b over 2a plus or minus the square root of b squared minus 4ac over 2a. So when you look for the LCM of both sides and then join, that will be x is equal to minus b plus or minus root b squared minus 4ac over 2a. So this is the quadratic formula. I remember when I was back in secondary school, we used to call it the almighty formula because of it was able to perform every calculations and to look for the roots of most equations that we didn't even think they had roots. So now this is the quadratic formula, and then I will not be giving an example, but I will be giving you a work. Can you try looking for using this formula? Look for the root of 3x squared minus 5x minus 7. So if you can do that, that would be good, and then you should get an answer of 2.57, or x is 2.57, or x is minus 0.91. So you can pause this video and try it out. Look for the root of the equation 3x squared minus 5x minus 7. Let me give you a hint. The hint is that your a is 3 and your b is minus 5 and your c is minus 7. So using the substitution method I talked about earlier in the revision section of this course, you just substitute your values for b, your values for a, and your values for c, and then you work out your answer, which you will get as the root of your equation. So having done that, let's talk about another section of this video where we'll talk about how do we get the root, what is the connection between the root and the equation. So that is where we talk about the sum and product of roots. The sum and product of roots is the connection between the roots is the connection between the equation and the roots of that equation. Okay, now let me express it simply in simple terms here. Now, for example, we have an equation. Now, the roots of the equation are alpha and beta. Now, this roots of the equation, it means that x equals to alpha in the first instance, x equals to alpha, and x equals to beta. So that means x minus alpha is equal to 0, and x minus beta equals 0. So that means if we multiply this, we'll still get 0. So in other words, x minus alpha times x minus beta equals 0. When you expand this equation, you have x squared minus open brackets alpha plus beta open close brackets x plus alpha beta equals 0. So you can see that in the coefficient of x in this equation is the sum of the roots, and is the negative of the sum of roots, and then the coefficient of the constant term is the product of roots. So you can say that if you compare this to an equation, ax squared plus ax squared plus bx plus c equals 0. When you compare it, that means you can see that when you divide through by your divide all through by your you have x squared plus b over a, bx over a plus c over a equals 0. So when you compare with this one with this one, you see that means b over a is equals to minus alpha plus beta. So in other words, minus b over a equals sum of roots, and then in this c over a is equals to product of roots. So product of roots is equals to c over a. So this is the relationship between an equation and its roots. The sum of the roots is equal to minus b over a, where b is the coefficient of the second term and a is the coefficient of the first term. Then the product of roots is the value of c over a. So where c is the third term, that's the constant term, and then a is the coefficient of your x squared. So I thank you for watching this video up to this end, and today we've talked about how to solve a quadratic equation using the factorization method. We'll talk about completing the square method. We'll talk about the perfect squares, and then lastly we'll talk about the quadratic equation, where I gave you an exercise to do. And then today we've been able to express a relationship between sum of roots, product of roots, and the equations itself. So thank you for watching, and see you in the next episode.